So the last thing that we'll go over today is comparing the two different types of nephrons that we have. So what is a nephron? What does a nephron do? Filters the blood, right? And produces what? Urine. When we look at nephrons, we said they're mostly located in what part of the kidney? Out in the cortex, right? So the nephrons are mostly located out here in the superficial part of the kidney, which is the cortex. When we look at a nephron, it's got two major regions, right? It's got this big head region, the renal corpuscle, where we filter the blood and we produce fluid. And then remember, it's got this tubule, right? With the PCT, the loop of Henle, and then the DCT. And we said that each segment of the tubule has a different function. We haven't gone through them yet, but I will tell you right now that the loop of Henle, this nephron loop, is extremely important for the reabsorption of water, okay, and sodium chloride. But remember, water follows the salt, right? So this loop is incredibly important for reabsorbing water. Now, when we look at the two different types of nephrons that we have, we can classify nephrons as being cortical nephrons or being juxtamedullary nephrons. Cortical nephrons are named cortical, right, pertaining to the cortex, because they're located almost entirely out in the cortex of the kidney. So meaning the whole structure, including that loop, is almost completely out in the cortex. Barely anything drops down towards the medulla. These are by far the most common nephrons that we have. Okay, most of our nephrons are cortical nephrons. These are kind of like the normal nephron. And when we look at the loop of Henle, it's relatively short. Okay, or kind of normal. Because of this, it reabsorbs kind of the normal amount of water. Okay, average normal day, most of your blood's being filtered through cortical nephrons. You're reabsorbing normal amounts of water. Everything's in balance. Everything's kind of average. After the efferent arteriole that, remember, leads out of the glomerulus, that flows directly into the peritubular capillaries, and then from there into the venules, and then out of the kidney. Remember, peritubular capillaries are, I drew this kind of long. Peritubular capillaries are the capillaries that go around the tubules. Because remember the whole point here, right? We filter out this fluid out of the blood, right? And then the fluid goes to these tubules. And remember, in the tubule, what are we doing? Reabsorbing stuff. Okay, so we reabsorb stuff from the tubule, and it's got to enter the bloodstream somehow. It does that via the peritubular capillaries. So the peritubular capillaries are these blood vessels that surround the tubules, so that when we reabsorb stuff from the tubules, it can enter back into the blood. Okay, so when we look at our normal cortical nephrons, blood goes in via the efferent arteriole, it comes out via the efferent arteriole. That efferent arteriole flows directly into these peritubular capillaries, and then into venules, out of the kidney. That's it. Juxtamedullary nephrons are weird. Medullary, because we're involving more of the medulla. Juxtamedullary nephrons are more rare, and when we look at them, they have a very long loop of Henle. The loop of Henle is much longer, so it drops down into the medulla more. So instead of just being like this, it's like this, not that long, but it drops way down more into the medulla. What did we say the loop of Henle is important for? Reabsorbing water. So if you have a longer loop of Henle, what do you think you do more of? Reabsorbing water. Okay, so you reabsorb more water when you shift to the juxtamedullary nephrons. Okay, so this means that the kidneys are able to excrete very concentrated urine. Okay, so really concentrated, you can get rid of lots of wastes without getting rid of lots of water. So this would be really important, for example, during dehydration. Important in dehydration. We still need to get rid of our wastes, but we can't stand to get rid of any extra water. We need that water. So we shift to the juxtamedullary nephrons where we can reabsorb more of that water. Also, we see that we have additional vessels present here. We have our peritubular capillaries that are present up around the convoluted tubules, but then we have these really long capillaries that drop down around that long loop of Henle, and we call those the vasa recta. I've got pictures right here, and then I'll be done. So here we see the two different types of nephrons. Cortical nephrons are much shorter, okay, and they're located almost entirely in the cortex. So this is the cortex, this is the medulla. And cortical nephrons are almost completely in the cortex. That's most of our nephrons. That's what we utilize most of the time when we're reabsorbing normal amounts of water. This is a juxtamedullary nephron, right by the medulla, hence the name. It's got a really long loop of Henle, and that long loop of Henle reaches way down into the medulla, and it allows us to reabsorb a lot more water so that we can keep the water in our body, not in the urine, and we can excrete a really concentrated urine. This is our normal cortical nephron, right? The blood goes in via the efferent arteriole, and it gets filtered out and goes to the tubules. The blood leaves the glomerulus via the efferent arteriole. That flows directly into the peritubular capillaries, right? So all of these little capillaries that surround these tubules, these are all peritubular capillaries, where we're reabsorbing everything, and then we go into these little venules and out of the body, or out of the kidney. This is a juxtamedullary nephron, a longer loop of Henle. So notice the blood leaves the glomerulus via the efferent arteriole. We have peritubular capillaries all up here, twisted or all up around the convoluted tubules. But when we look at this really long loop of Henle, notice these long straight vessels, right? That's the vasa recta. So we go peritubular capillaries, vasa recta, then into the venules and out. Sorry guys, that's it.